All right, we are live. We are back at Monero Talk. We somehow managed to get Andrew Poelstra back on the show. Great talk this morning. So that panel was on privacy coins. I know we had you on the show. We went over a lot of things. What's your current take on Monero these days?
My current take on Monero. So I've heard. I'm going to take the mic from me. So a lot of what I've been doing lately is a scriptless script, kind of hiding things inside of Schnorr signatures, hiding things inside of multi-signatures, so you can do Lightning, payment channels, all the cool stuff. The big limitation in trying to do cool things inside of signatures is there's no way to do time locks. So, well, let me start by saying how this applies to Monero, because that's really your question, right? The Monero has Schnorr signatures. I don't know how widely this is known, but Monero uses the ED25519 signature algorithm. That is a special case of a Schnorr signature. So in principle, all of this cool Schnorr multi-signature crazy stuff that I've been talking about could be used in Monero today. But the big thing that Monero doesn't have, and this is very difficult, it's inherently very difficult to put any sort of scripting support into Monero, because the way that scripts interact with ringct is, it doesn't really make sense. So what Monero needs is some way to do time locks, to do most of the cool things that I'm talking about. There's this primitive called claim or refund, where whenever you're doing an interesting contract, somebody has to put some coins up, the counterparty walks away, the first party needs to get their coins back. To do this in Bitcoin, you have what's called a time lock. There's a time lock opcode. It's called opCSV, which stands for check sequence verify, which is like not meaningful at all, but it means time lock. Monero has no such construction, as far as I understand. And the reason is that Monero does not have a scripting system the way that Bitcoin does, or the way that other things do. And the reason for that is that there's not really anything as like a ring script satisfaction is what you would need. In Monero, of course, whenever you're spending an output, you refer to 7 or 9 or 11. I forget the number now. Up to 11. Wow. You're referring to 11 old coins. You're saying, I know the secret key to one of these 11, but I'm not saying which one. You can't say, like, I'm satisfying one of these 11 scripts, but I'm not saying which one, right? That just, like, inherently would be privacy violating to do. So there are some cool ideas that I believe we'll hear about at MoneroCon in Denver. I'm not really involved. For getting some form of backup or, like, claim or refund construction into Monero. And that's actually what Brandon was talking about on stage earlier today. And if Monero had that, then suddenly Monero would become a test bed for a lot of this cool scriptless script application that I've been talking about. And I hope that a lot of the software and engineering development that I've been working on, getting these things working for Bitcoin and for Liquid, will be ready enough by then that we could actually start thinking about playing with it on Monero. That's what excites me about Monero today.
That sounds great. And what would be the practical applications with that?
So for Monero, this would be a way that starting from nothing but claim or refund, which is relatively simple, you would be able to run Lightning on Monero, basically. That's a big jump, but the blockchain support that you need for it would be there, which is exciting because until these scriptless script constructions started coming out, it was sort of believed that you needed some sort of hash and hash pre-image, like some sort of scripting support somewhere that, as I mentioned, Monero is fundamentally incompatible with. So an application for you guys is like, we have, you could have Lightning on Monero, which is or like atomic swaps, or like private exchanges, or even something like Tumblebit, which is where you have, like you're doing an atomic swap with a server who is providing blind signatures, and the server doesn't even see which coin it's swapping with. So it's a privacy-preserving swap tool. It'd be applications like that. That's actually an application that would apply to Bitcoin and anything else that has Schnorr signatures as well. And then for something like Bitcoin, where we already have all these scripts, these script constructions, in principle, we're not really adding anything new. But in practice, we're letting us do things that we're doing now, like atomic swaps and Lightning and so forth, in a much more private and a much more scalable way. So that's the real application, is making existing things more efficient, more private, more scalable, and more extensible in some ways.
Sounds good. Do you have any new info on where you think Monero may go in terms of potentially swapping out ring signatures with a different technology? Are you in the know on that?
I am almost in the know. I idle on the Monero research channel, and I'm aware of some of the ideas that have been thrown around. I believe one of these ideas come from Tim Roofing and some co-authors of his. I work with Tim closely at Blockstream, and I guess I should know what he's doing. I'm technically his boss, so like I should know what he's doing, but I'm going to be honest, I don't know what he does. I haven't been following that too closely, but I understand that he has a ring signature scheme that is logarithmic sized, although it still doesn't give us logarithmic verification time. So this would be, if we were to deploy this on Monero, it would be a small but not like earth-shattering efficiency improvement. Longer term, there are some ideas that would actually give you log scaling in size and verification. For example, you could literally like look up every single output in a giant Merkle tree, pick one, say, I'm going to spend this, so you're exactly identifying the output, but do the whole thing inside of a zero knowledge proof. And then that would actually give you basically a ring of the entire output set, which is exactly what Zcash has, actually. But the technology is not quite there yet in terms of general zero knowledge proof. We need a zero knowledge proof scheme that had no trusted setup, that was very efficient to verify, and that was reasonably sized such that you could put it in a blockchain. And we have a bunch of things that get 2 of those 3. And like, you pick any 2, I can give you a scheme that does that, but we're not quite there. So my hope and dream is that in the next like 5 years, maybe, we'll see some technology breakthroughs there. And then once there was such a thing, it would be such an overwhelming clear win that it would surprise me if Monero weren't going to pick it up.
It would surprise you what?
If Monero didn't pick it up.
Okay.
But we're just not there. It did not exist yet, what I'm looking for.
Yeah, and hopefully we would be the early adopters of such technology. So I touched upon this with you the last time you were on the show, and Brandon spoke about it a little bit this morning, and it always comes up with anyone I talk to that's really in the know. This whole Monero and being computationally binding and perfectly blinding, the fact that you can't be both perfectly binding and perfectly blinding. Any new insights on that, Brent, and any response to what Brandon was mentioning this morning in his talk regarding that?
So, yeah, I can elaborate a little bit on this. So the issue is the commitments. Instead of having amounts in Monero, we have confidential transactions. All the amounts are replaced by commitments. There's fundamental trade-off you can make, right? These commitments can be at most one of perfectly binding, meaning you cannot open them to anything except for the value that you want, or perfectly hiding, which means that there are a few different notions of what that means, but essentially it means that there is no way, even for a computationally unbounded adversary, to figure out what these things are open to, what a commitment will open to. And for back in the good old days of like first version of Ring CT, there was kind of a trade-off you could make, where you would take a slight efficiency hit to get perfect binding, but if you didn't want to take that hit, you might otherwise take perfect hiding. Now that Monero is using bulletproofs, we no longer have such a nice trade-off. Like the only way to get to perfect binding is to throw away bulletproofs and like go back to something like these enormous ring signatures. But there may be in future kind of an intermediate, like if we have like one of these like dream crypto systems that I'm talking about, like something like Starks, you may get to something where you only have computational soundness, meaning that a computationally unbounded adversary would be able to create fake proofs. But the computational assumptions there, rather than being something like the discrete log assumption, which we know will be broken by quantum computers, might be something much stronger, like that hash functions behave reasonably randomly, or even that like hash functions that don't have collisions. And that's maybe a level of soundness that I expect people, even people who are uncomfortable with the current elliptic curve discrete log level of soundness, could probably most of those people would be comfortable with that. But well, there's one more thing that I want to say, like a philosophical thing, is that we often talk about these things, or I often talk about these things, like the soundness is like the worst thing, like the biggest reason I feel to use Bitcoin over like anything else. One of many big reasons, but the biggest is that Bitcoin is sound. Like you look at the blockchain, you can immediately see that there's no inflation has occurred. Like Bitcoin only has one asset, but no transmutation or anything crazy like that has occurred. And replacing that soundness guarantee with something that was only computational would be a tremendous loss. And I think that any proposal to Bitcoin that moved us in that direction wouldn't be able to pass the community muster for this reason. But there's another way of looking at this, which is to say, look at something like Monero or like a Mimblewimble design where you're using these computationally binding, perfectly hiding Peterson commitments. What it means for them to be perfectly hiding in this case is that an unbounded adversary could actually open every single commitment to any value that's possible. So if tomorrow there was a quantum computer that appeared, then, let's see, so Monero is a bit complicated because of the key images, so I can't say anything hard, but it's a bit complicated because of the key images. But I'm going to say something really dramatic about a Mimblewimble chain, which is if a quantum computer appeared tomorrow, every single output on a Mimblewimble chain would be openable to any possible value, meaning the chain completely deletes itself. No privacy loss because everything's deleted. All the money is gone, of course, everybody's screwed, but no privacy loss, just deleted. And this is really kind of magical, right? I mean, that doesn't happen in computer science. You can have a blockchain of all things, that you have this publicly available data that is permanently, like there are copies everywhere that people are verifying and storing and archiving, and it just goes away. It becomes meaningless. And that's a really cool feature. And I feel like the trade-off between having that ability and having perfect soundness is not as clear-cut as a lot of people make it out to be. It's actually a very interesting philosophical question about what you want.
And so, I mean, so this concern about something like Monero potentially not being fully secure for all these reasons you're talking about, is that a real concern today, though? Because, I mean, this is like, and does that slowly go, obviously, like we're saying, there might be new technology that would allow us to move closer towards being perfectly binding, which I would think the Monero community would certainly be moving towards. But is it a real fear today? I mean, we're talking about it being a fear in terms of quantum computing being able to make, attack. But wouldn't there be a lot of other bigger concerns at that point? I mean, is Monero, don't a lot of things fall apart? Wouldn't Bitcoin itself potentially fall apart?
So I've got to run soon, so this will be my last question. There are a few different things there that I could address. So the first question is, like, is this a threat today? Like, the only threat we're aware of to the elliptic curve discrete logarithm problem for the curves that we're all using are indeed quantum computers. The question is, when will we have, if we will have a quantum computer that is large enough in terms of qubits that it can keep coherent at the same time for a reasonable amount of time to be able to break the elliptic curve discrete logarithm problem. And I don't study this as much as I wish that I did, but people give me numbers on the order of like many thousands of qubits. And I am probably one of the most, like, the sky is falling hysterical people you'll meet about this, and it would shock me if we saw such a thing in the wild, like in less than 15 years, say. And probably you'll find people at this conference who will give you a number like 25, 40, 50 years, or like never. Some people think it's not going to happen. So it's not an immediate concern. I'm not saying today, nobody's saying today, but because these things take time to develop, it's good to talk about it today and good to try to move towards systems that are resilient against this sort of threat. And then your second question, actually, I'm going to jump to your third question first, which is, like, wouldn't Bitcoin be screwed as well? And what would happen with Bitcoin? All of the coins would be stealable, basically. So the soundness of the system would be retained in that everyone could guarantee that no inflation would happen. But of course, all of the coins would be stealable. And some people like to talk about how in Bitcoin, many elliptic curve keys are hidden behind hashes. This isn't really, in principle, the system supports this, and in principle, people use it this way. In practice, almost all, like well over half, something like 2/3 of all of the public keys that control coins in Bitcoin today are exposed. People know what those public keys are. So given a quantum computer, they could just steal all those coins. Okay, so for Bitcoin, the situation wouldn't be a lot better. But what's better in the Bitcoin world is that our transition plan, were we to need one, would be much simpler. Because in Bitcoin, we only need to replace the digital signature algorithm to be quantum secure. In Monero, you have to replace the ring CT. You've got to replace, well, both CT and the rings. And then those together are such an integral part of the system and so complicated that would be a much more difficult transition than just replacing the signature algorithm the way you would in Bitcoin. And then going back to your second question, which was basically the third, wouldn't other things be a bigger deal than Monero? And I think usually what people, when people ask me that, they mean like the bank system and like SSL. I think it's hilarious that you went to Bitcoin and not that. That's wonderful. We're winning. Yeah. So, but some people are using like this legacy financial system with like, I mean, it's a couple quadrillion dollars. It's peanuts compared to Monero. But some people are still using that, mostly old people. And would their coins be at risk? Would their coins, they call it money, I guess, their coins. Would their coins and their banks be at risk? Yeah, there'd be chaos. Like, holy shit, like what a mess. So like the SSL, when you connect to a secure website, the SSL handshake that you do, that would be compromised. Any asymmetric crypto used in interactions between banks, I think that's used in a lot of places. It's not used as pervasively as you might expect. There is actually a lot of symmetric crypto in the way banks are today. Like ATMs talk to each other using like symmetrically encrypted PIN things, and they're like secure hardware chips that have secret keys burned into them because they aren't using this asymmetric crypto. So the symmetric crypto, mostly okay, other than the bit security would be halved. Everything 256 bits would be 128. Anything 128, or is it 2/3? I think for decryption it's 2/3. For collisions it's 1/2. There's a reduction in bit security, but it's not catastrophic. For stuff like that's using RSA rather than elliptic curves, there is actually more quantum resistance than there is for elliptic curves. So with classical computers, we think about like 2000-bit RSA as being roughly equivalent to 190-bit ECC, and we're all using 256 bits. So like, yeah, we're better than 2000-bit RSA. But the quantum attacks, the Shor's algorithm, actually looked at the bit lengths. It doesn't care about all these cool breakthroughs we made with classical RSA algorithms. For a quantum computer to attack a scheme, it just looks at the size of the group that you're looking at. And so for a quantum computer, 2000 bits is a hell of a lot more than 256 bits. So it could be that the EC stuff, meaning some modern SSL handshakes that we could just disable, and cryptocurrencies, basically, and some key fobs and some stuff like a lot of fairly minor stuff, most of which could just move to RSA or move back to RSA, would potentially be unaffected until a much later date. The only thing that can't move to RSA are these cryptocurrency applications where that would be just such an enormous key size explosion that it would make the whole thing infeasible to run.
So what I'm hearing, following your logic though, because what I don't really understand is that's kind of the largest argument against Monero right now. But it seems to be not really a problem because we have, at least 15 years to fix it. And isn't it worth the sacrifice to be fungible today, to be digital cash today, and then continue to fight to maintain it, as opposed to what Bitcoin is doing, which is ensuring its future security potentially. But like you said, if quantum computers existed, it would still mess up Bitcoin anyway. So I'm not really understanding why that's worth the sacrifice at that point. Wouldn't Bitcoin then want to become fungible at the core protocol level? Wouldn't it want confidential transactions? And shouldn't Bitcoin people be more excited about Monero because it's achieved fungibility and it can continue to fight and evolve to maintain it and be ready for when these quantum computers arrive?
So if it were really about just like that one decision about quantum hardness versus privacy, then I would indeed be advocating that people use Monero, at least for like short-term coin, maybe not for like long-term stuff that they're holding and they hope to be around in 50 years or something. But I would advocate people do the day-to-day transacting in Monero, and I would be advocating for Monero-style technology to come into Bitcoin. But what the blocking is not so much the specific issue of soundness, but kind of a wider issue of the ethos around Bitcoin being extremely conservative and very averse to any change that could harm the robustness of the system. So in the Bitcoin view of cryptocurrency innovation, basically maintaining the continuity of the system and the robustness of the system to large changes is the most important priority in the immediate term. Meaning that anything like any of the technology Monero uses would be seen as like very large and very complicated. And like the soundness aspect is like one part of that aspect. But the thing is you're bringing all these new crypto assumptions in much larger and more complicated ways into the system. And it would be a very dramatic change, and it would have a very dramatic effect on the security properties of the system. And there's an aversion to that, right? So the Bitcoin view is the way that I see what most people in the Bitcoin community feel about these kind of questions is that it's better to keep the system robust and have this kind of innovation bringing us towards both robust and private and like all these great things. That kind of innovation, let the Monero people do it. And like if it like blows up in their faces, you know, it's just Monero. But if something like that were to happen, if it were to blow up in Bitcoin's face, that would be catastrophic, not just for Bitcoin, but for the whole ecosystem. And I think everybody probably agrees with that. Bitcoin is really the elephant in the room. They're what people see when they look at the cryptocurrency space. Is the first thing they see. And it's really important to present ourselves as being a extremely resilient system. Because ironically, Bitcoin is seen as like being some crazy hacker experiment versus the existing financial infrastructure. And despite Bitcoin's reputation within the cryptocurrency space as being like the grandfatherly old, slow to move, slow to innovate kind of thing, that's our perception that Bitcoin is kind of like waving the flag for cryptocurrency to the world. And the most important thing there is resilience, because otherwise it's game over and we don't really even have the opportunity, potentially, to be continuing to do the kind of innovation that we are. So it's wonderful that Monero exists and it's doing what it does, and that people have that kind of attitude, that they're willing to use this and are willing to make that trade-off. But as an ecosystem, that's a different trade-off than as an individual, I guess is what I'm saying.
Yeah, very well explained as always. Yeah, I think it is worth the trade-off, and I think because I think the goal is digital cash or digital gold, whatever you want to call it, and I think you need to get there first before you worry about security, because at the end of the day, what are you really securing if it's not actually digital money or digital gold, right? And gold is certainly fungible, cash is fungible. So I don't see why that wouldn't be priority, is to get there first and then figure out security. I mean, obviously, Monero isn't sacrificing security, but its priority, I think, is to achieve digital cash and maintain itself as digital cash. So every unit of Monero equals every other unit of Monero. So I just find it hard to digest and understand why that's not a priority in Bitcoin. I get that, you know, if you're going to have the whole world using this as a financial tool, it needs to be secure, but doesn't it need to be digital cash first? Because this is what, you know, as we all opt onto this system, there's no turning back at that point. So don't we want to get it right before we ossify it?
So what Monero does in this pursuit of getting it right is there's a tremendous rate of innovation. There are new hard forks in Monero every 6 months. There's new crypto systems, and most of these hard forks have been dramatically new crypto. Things are iterating, getting better all the time. But all of the kind of ethos shaking, like scary, fast movements that are happen not only just like in a transition from a Bitcoin-like system to a Monero-like system, but in a Monero-like system, those kind of transitions are constantly happening. So if your goal is to get digital gold first, then like it almost seems like there's no reason. Like they're far away from that, basically. And there are more. I guess to your comment about this being a priority in the Bitcoin space. First of all, it is a priority, but again, the most important priority is that the network continues to run, that the network is resilient. And then privacy and fungibility and all these great things, ultimately you have to defer to that, is really the difference. It's not that it's not a priority, but it's not the number one priority. And the reason, let me think about what I want to say about why that ordering makes sense. It's essentially that there is more to a cryptocurrency network than the digital gold aspect. It is not only that you have a perfectly fungible, perfectly privately transferable asset. There's also network effects. There's a peer-to-peer layer. There's things like assurance. There's like proof of reserves, for example, is much easier. If you're not going to do it privately, it's way easier. And even if you're doing it non-privately, it's easier on Bitcoin than on Monero. There's tooling, there's custody, there's key management. There are all these aspects of the system that need to be developed. And they need to be developed by parts of the industry, meaning now I'm like very wide, like financial industry and the computing science and like in addition to security, there's all sorts of different industries that come into play for all these different aspects of the system. And with the exception of like privacy researchers, I guess privacy researchers are the kind of people who can drive us towards that digital gold. But all these other categories, all these other components of the ecosystem that need to be developed are being developed by people who generally share that prioritization of resilience over privacy. And if we were like as the cryptocurrency community, like purely focused on Monero style, like privacy at all costs, let's get digital cash first and then like look around and try to make this usable kind of thing, then a lot of the innovation in those dimensions wouldn't be happening. So like, I would not want to see such a world. That's my answer. Yeah.
All right. Hence the existence of the Monero community and the Monero coin.
Yeah, absolutely.
All right. Really appreciate your time and your well thought out answers as always. Look forward to following you and hearing more from you.
Cool. Yeah. Thank you. Have a good one.
Thanks, man. Yeah. Thank you very much. I think we'll get Brandon right now too. All right. That was amazing. You want to grab Brandon?
Great. Hi.
Thanks, man.
Yeah.
Oh, wow, this is awesome. We just had Andrew, and now we got Brandon. We're peaking right here. Monero Talk is peaking right here. Hopefully not in terms of price. Hopefully, but we got to move over. So I was talking to Andrew, and I constantly rehash this on the show, and it's great to really hear Andrew on it. Basically, this whole perfectly binding versus perfectly blinding, and the fact that you can't be both. You touched on this morning in your talk, and Andrew's take is, I'm sure you know, that in Bitcoin, the idea is the number one priority is security and making sure you maintain the network. So they're not willing to sacrifice that with implementing something like confidential transactions, where you lose that perfectly binding aspect. Although he said it's not really a risk until you have quantum computing, which I think we have some time to work towards. So my question to you is, number one, will Monero work towards being more perfectly binding in addition to blinding? And my second question is, do you agree with what Bitcoin's doing in that they're making that their priority, that they're not trying to build digital cash first, whereas I feel like in Monero our priority is let's build digital cash and then let's maintain it and do what we need to do to. Whereas in Bitcoin, they're like, we've already arrived, we're ossifying, and we just want to be secure. So I know there's a lot, but it really boils down to two questions there.
Okay, so let's start with the commitments and bindingness. So one of the things, I'm not sure if you can hear me, but I think that'll work. One of the things that I spoke about in my talk today was the switch commitments that were first invented by Tim Ruffing and Malavolta. And the thing is about those is instead of being able to lie about the amounts, right, you're going to be able to peak on amounts. And so we have a trade-off to go through, right? Either somebody can lie and mint money by sending negative money, or somebody can peek in and like violate privacy. And unfortunately, there's a hard limit in the universe. You can't have both. That's provable. So one thing that we can do is switch over to switch commitments, like I just mentioned, that remove the binding property, or that's kind of like trade up the binding properties, so that we have something that's everlastingly binding, but only computationally hiding. And this is like a suboptimal solution for Monero, because we would like to hide Monero's transaction amounts. It's really easy to link transactions by transaction amounts. And in fact, jumping in and out of the Zcash shielded pool, that's one of the easiest ways to de-anonymize Zcash, is to look at transaction amounts and timings and then just be like, oh, this guy got 5 Zcash at noon, and then an hour later, 5 Zcash exactly was sent over here. Gee, I wonder what happened. So since we have this trade-off between the binding and the hiding, it's not totally clear to me exactly how things are going to unroll over the next couple of decades. But I do have to say that I appreciate the Bitcoin core team's ability to focus on security. Personally, in my world, Monero is pretty good as eCash already. Just to be clear, I said eCash, not Zcash. Monero is perfectly good as electronic cash, in my opinion. But people are using it to protect themselves, right? And so they're dealing with the people who are using it to protect themselves are dealing with situations where their life might be on the line. And in the case where you have something like that, security absolutely has to be a priority. If I make a recommendation to the Monero development team as a researcher that ends up causing somebody to be executed in Venezuela, or North Korea or something like that, I'm not. Like, there's a chain of indirect culpability there, right? Like, maybe I'm not the one who's responsible. Maybe the developer who implemented it is, or maybe whoever pushed it to the code base is, or so on and so forth. These are things that I struggle with a lot. Personally, my attitude is safety first, privacy first. And then if we can manage to do neat things like colored confidential transactions or something like that, all the better. But if we can't have a private version of Lightning for some reason, because of the way that our structure is set up, and the only way that we can get a Lightning network is to violate people's privacy, I'm not willing to do that. And I don't think Andrew Poelstra is necessarily willing to do that at Blockstream. And generally, I think for cryptography-based protocol applications, you absolutely have to start with security and safety first. Right now, I can send you a Monero transaction unless we both have exchanges peeping on us on either end of the chain. Like, nobody's really going to be able to tell. And there are some threat models where things could be linked, but our main focus is on privacy. Yeah.
So this meme criticism of Monero that it's perfectly blinding but not perfectly binding. Do you think that's going to slowly go away?
I really hope so. And the reason is because if we went the other direction, right, then we would be getting the opposite criticism. And they'd be like, oh, it's not perfectly binding, it's perfectly blind. You're just going to switch it up. And so we can't win. I think there's a certain level of FUD or propaganda that is related to criticism when it comes to deciding between those things. We decided on making sure that we had perfect hiding for privacy purposes because quantum computers are quite a while away. If we decided to switch over to perfectly binding or everlastingly binding with our commitments, we're just trading one threat model for another.
Awesome. So your talk was great this morning. Unfortunately, I missed like the first 5 minutes of it. Rough night last night, to say the least. I guess you don't have to go through the whole talk again. Ring signatures. When are we getting rid of those? What are we doing? When's that update coming? I know there's no timeline, but are we moving in that direction?
Yeah, everybody absolutely agrees that ring signatures are the worst part of Monero, but it's also like the heart of Monero, or CryptoNote anyway. And we have a lot of possible proposals on the table for sublinearly sized ring signatures. We're never really going to get away from ring signatures until we have something that's trustless, like a Stark, that's sufficiently efficient to not drag the network down. One of the reasons that nobody ever used shielded transactions with Sprout and Zcash is because it was just too damn slow. And so it doesn't matter if you build a perfectly hiding system if nobody uses it, right? Right now, there are a couple proposals out there for ring signatures that are much more efficient, and we're looking through them very carefully. I would like for ring signatures to be replaced with something better sometime in the next 2 or 3 years.
Oh wow, that's aggressive. That's sooner than I thought.
Well, let me phrase it a little bit different. I hope that we have a solid proposal that the community can get behind within the next 2 or 3 years. But if that proposal is based on brand new cryptographic assumptions or like a brand new protocol, then it's just as dangerous to implement as like picking something random out of like IACR or like Archive and then just trying to throw it into the Monero code base. So my goal is that we have a clear target for what we're switching to sometime in the next 3 years. To expect us to switch in 3 years, that's not what I'm trying to say. But we have kind of a similar thing going on with our commitment schemes and our range proofs.
That's very exciting. And do you think we'll learn more about that at the Denver conference, Monero conference?
Yeah, so there is a conference happening in Denver, and Monero Talk is our media partner. June 22nd and 23rd, we're having a lot of great technical talks. It's a technical-focused conference. Although Magical Crypto Friends has had a lot of good technical content, this is still like on the lead up to Consensus, which is largely a business event. The Monero Conferenzo, it's Esperanto for conference. It's going to be much more technical. And I know of at least one talk that is a proposal for a different ring signature scheme. Super excited to hear that talk, but I can't give anything away about it, in part because I haven't read the paper yet, but also because I've been asked for a little bit of confidentiality. But it's going to be really, really great, and I strongly recommend that people show up.
I'm going to have to cram cryptography, if that's possible, before the event. I wish.
Maybe.
What was the? I had another good one I wanted. Oh, the recent paper that came out about the flood attack.
Yes.
Do you want to talk about that? You talked about it this morning, but if you don't mind, kind of rehashing that.
Sure.
Your opinion on it.
Yeah. So flooding attack was recently described in a paper. I think it was only a couple of days ago. But they were describing a lot of different properties that we've known about for a couple of years. That's not really an excuse because, we knew about this flaw. It doesn't really help people when they're using Monero to protect themselves. Having said that, the paper has some flaws in it that need to be rectified. And to be, let me put it really carefully. Okay, let me just describe really quick for your audience how it works. So if I flood the Monero network with a bunch of outputs, and then other people use those outputs in their ring signatures, then I can tell that I didn't sign those outputs. I didn't sign those ring signatures with those outputs. So anybody who floods the Monero network with a bunch of outputs, well, that can be pretty cheap. You just send money to yourself. You pay transaction fees, but our fees are pretty low. Anybody who does that is then going to have like a pretty good chance of de-anonymizing the Monero network. Or let me rephrase that. They'll have a pretty good chance of learning some ring members that were not used and reducing our effective ring size. However, the effectiveness of this attack decreases as the number of attackers increases. And it's cheaper when there are fewer attackers. So an attacker is incentivized to attack when things are cheap. And when they do so, a bunch of other people make the same decisions and they jump in, and their incentive structures are all aligned to do the attack simultaneously. What ends up happening is by jumping in and not colluding with each other, they're actually making all the attack less effective. So everybody's induced by incentives to sort of try this, or at least not everybody, but the people who are interested in de-anonymizing Monero. But as more people start doing it, it becomes less effective and more expensive to do. So below a certain threshold, you have a bunch of people who are attacking more and more and more. And above a threshold, it's too expensive to attack. So people stop attacking. And you end up with like a nice equilibrium level where no one party is capable of doing what is described in that paper. Now, having said all that, it's super cheap for a single individual to flood the Monero network over a very, very brief period of time. And in that scenario, things get a little hairier. So what I would do if I were a drug enforcement agent, I would probably flood the network for like a 24-hour period and then go try to like make a controlled purchase from a vendor that I know is selling something illicit. And then what will happen is that vendor will then go cash out in an exchange. And since I flooded everything recently, I'll be the only one who knows that I'm conducting this attack. But again, the incentive structure, as I just described, is set up so that this is unlikely to really be effective. In fact, one could argue that there are going to be as many attackers as there are nations, at the very least, right? Because every nation has at least one 3-letter agency that's interested in doing this. And so if the number of attackers reduces the effectiveness and every nation is interested in doing it, or at least every big nation state, that's not a very effective attack.
So kind of separate from the game theory aspect of it, are there other things that can be done to kind of avoid the effectiveness of that attack and eliminate the attack?
Yeah, this is actually one of the first times that I've come across an attack. Okay, let me rephrase that. Are there more mitigating strategies? I imagine that if you had something like ZK snarks, then you would have something that would be rather resistant to an attack like this. But anytime that you have small anonymity sets and you have the ability for anybody to arbitrarily at ad hoc create new outputs, you're going to suffer this problem. And so I actually haven't thought about this attack at all with respect to Zcash. And that's usually how I go about this. I'm like, well, is our threat model worse or better than Zcash? And what would happen if we had snarks or starks, which are trustless versions of snarks? In the end, I don't really have a good answer for you.
How about increasing the amount of decoys? Is that something that would have an effect?
Yeah, so one person could try to just flood the network themselves, right? And then just throw out a whole bunch of decoy outputs, and then they're acting as an attacker. And so you've just increased the number of attackers by one, which reduces the effectiveness and improves the increases the cost of the attack. So there could be honest actors out there who just decide to start flooding the network with fake outputs specifically to try to like obfuscate that event. But of course, that starts a bidding war, because as they join in, the attack is more expensive. So then the attacker pays more money. So then the defender pays more money, and so on. And usually the attacker is going to be the one that has all the money, right? So although there are certain strategies like increasing ring signatures that would help, or putting out decoy outputs, overall, this is an ongoing problem that we've been thinking about at Monero Research Lab for like several years, and we never really come to any good answers.
So I know, like we spoke about ring signatures. Hopefully, we eventually move away. But do you think we'll be increasing ring signatures before then? Will it go up again?
Actually, that's a really good question. Right now, I'm working on certain simulations for determining how effective traceability attacks in general are as a function of ring signature size, because there's a lot of anonymity metrics out there. Not all of them make sense for our context, and nobody's really studied the Monero blockchain specifically with respect to those metrics. So I'm running some simulations right now. My current intuition about this, based on a couple of back of the napkin calculations, is like a ring size bigger than like 24, 25 is kind of unnecessary. And so, especially because we cap each transaction output to 16, right? Like no transaction can produce more than 16 outputs in Monero right now. So arguably 16 ring members would be like, in a sense, all we need. Your question was, are we going to be seeing an increase in ring size anytime soon? And I designed all of these simulations to determine whether or not it was a good idea to keep increasing our ring sizes. One criticism of Monero that's by the Zcash scientist Matthew Green that I do my best to learn from everybody. I do my best to listen to criticisms, because that's how you move forward, you get better. One criticism that Matthew Green made was that every time we increase our ring size, that implies that the previous ring size was not sufficient. And so ever since then, I've been like thinking about quantifying when we need to stop. And I don't think anybody else is thinking about how to quantify something like the anonymity set in Monero, because everybody's like, there's two crowds here, right? Everybody's like, oh, your ring sizes are 11, so your anonymity set size is 11. And then other people are like, but if you send a transaction to yourself, that's really 121. Then if you send a transaction to yourself twice, that's 11 cubed, whatever that number is. I forget it off the top of my head. And when you start playing that game, we know that the answer is somewhere in between. The actual anonymity set size, it's not 11, but it's not exponentially growing either, because there's an overlap. And so, as you look at this big growing tree of keys. So in the end, it's not totally clear whether or not we're going to be increasing ring size again. And if we do, it's not clear to me when that'll be happening. I'm not convinced we need to.
Okay. Why not just go to the 24 max, though? Then kind of the debate is over at that point.
Well, the short answer to that is 24 is like 1.5 times our current transaction or ring size. And so that would just naively increase the weight of the blockchain by 1.5. And so a year from now, the download and sync time for new nodes will be much, much higher than if we hadn't made that change. And if we're going to kneecap ourselves by 10 years from now, guaranteeing that nobody can sync to the network, then we're going to be in the same situation Zcash was with Sprout, that nobody's using your nice privacy technology, right? So to be safe, because being safe and privacy and security, as you mentioned earlier, are like really, really important, or rather you asked me about earlier. And as I claim, my primary concern is privacy and security in Monero. It seems like the safe thing to do would be to boost that to 24. But if the result is that everybody stops using Monero 5 years from now because it's just too bloated, then what did we do it for?
Awesome, man. Thank you for the amazing answers.
Yeah.
I guess final question. What do you think about the fact that like Monero is here? I mean, we're part of the Magical Crypto Conference. It's kind of like it's the new consensus. Is that significant? Is that any opinion on that?
You're just trying to make friends with Rick. Fluffy pony. I have a lot of thoughts on that. And no, I don't have any thoughts on that. I haven't thought about it at all. I never thought about Magical Crypto Conference as being the next consensus, but now I'm going to start thinking about it. It might keep me up at night a little bit.
I'm just saying it's good, right? The Monero is now part of.
Yeah. So one of the things that I find interesting is that Monero in general. So if you look at the New York Bit license, it appears to me that Monero is compliant with it, and regulators and exchanges seem to be hesitant to come to the same conclusion. But when I have phone calls with lawyers or regulators or something like that, it seems like they tend to agree with me. So in the end, I think it's great that Monero is being brought into the mainstream. I think that privacy is a human right. I think that being able to enable people in North Korea to buy a Bible, or people in Venezuela to be able to receive money from outside the country to help pay for food or rent. I think these are things that we should all be going for. Like, one of the reasons that we get into Bitcoin generally is because we're like, it's a global economy and it's permissionless and et cetera, et cetera. And I think it's more true for Monero than it is for a lot of the transparent coins. Having said that, the last 2 years have been absolutely crazy. There have been so many developments in cryptography, not just cryptocurrency, but cryptography, like the actual discipline of mathematics. And to see everything exploding like this and then be monetized it's weird. It's really cool because it's like a bunch of PhD mathematicians got together and they're like, we're going to make the 21st century money and it's going to be made of math. And you're like, yeah, I'm all about that. In the meantime, I'm just kind of like along for the ride and hoping. It's like surfing. It's like you're on the wave, you aren't the wave. It's not like traffic. You are traffic. You're not stuck in traffic.
I mean, yeah, I guess when you were studying cryptography, you never dreamed that you would kind of become a celebrity from it. And it's kind of like math on steroids now, right? I mean, there's, would I have ever known your name if cryptocurrency
you would have known my name.
didn't exist?
No, and what's actually funny is I didn't actually study a lot of math or cryptography in my PhD program. My math came from like a deeper level, like a lower level, more pure theoretic math instead of applied math. And cryptography is very much its own animal. It's applied mathematics, it's computer science, it's cryptography, it's a whole bunch of animals all at once, and game theory. And so, no, I never ever would have thought that studying for my PhD would get me on camera that's going to stream all over the internet, right? I mean, this is pretty crazy. And hosting a conference in Denver is having people fly out from all around the world so that they can like contribute to a productive discussion about the development of privacy technology, and that includes like on the sociological level, it includes on the legal level, on the regulatory level, on the mathematics level, on the computer science level. It's a little mind-blowing to me, and it's pretty overwhelming. But I do to the characterization of myself as a celebrity.
Well, you're a celebrity in my eyes. And I'm sure with most of the viewers here, you're doing an amazing job. We appreciate it.
Thanks, guys.
I can't wait to see you in Denver, man.
Yeah.
I'm very much looking forward to it.
Are you going to be doing interviews like this in Denver?
Yeah, I hope to do the same exact thing. Yeah.
Cool. We have a room set aside and set this up, and you guys can totally pull people off the stage right as they're done and drag them in and be like, "How you feeling about your talk?" It'll be great.
Awesome, man. Thanks again.
Thanks again.
Yep.
Have a good one.
All right. That was amazing. Back to back, we had Andrew Poelstra and Brandon. Like I said, I think we kind of peaked here. I'm signing out for now. So long.
Okay.